Here we have an example of two cars. One of them is on a path, circular path, which is defined by a radius of 100 meters, and it's defined by B here, and there's a reference frame attached to that. There's this B point at the intersection of these two coordinate axes, and then this green arrow defines its direction of the velocity, and then there's this car, red car, moving in the x direction at that instant of the time with respect to this body fixed frame, and this xy axis is moving with the car, blue car by the way. They have these constant speeds of 54 kilometers per hour and then 72 kilometers per hour, these car A and car B. And we are asked to determine the velocity which car A appears to have to an observer riding in and turning with car B. So there's this observer, there's this guy at point B, and then observing the motion of this car A, which is the red car. And it is moving and rotating with this car. So this car is in a general plane motion, we would call it like that. It's moving, it's translating, and then rotating about the z-axis state. There's an extra question here. The xy axes are attached to car B. Is this apparent velocity, there should be a comma here, the negative of the velocity which B appears to have to a non-rotating observer in car A? Now, to answer that question, we need to write out our equation. So let's write out our first equation. Velocity, absolute velocity of A equation. Absolute velocity of A is equal to absolute velocity of B plus the relative part, relative velocity of A with respect to B. Now, this relative part is composed of two things. One is the rotation of this car B, which is the frame of investigation. XY frame is rotating, so there's this omega, which is not given in the question, but we can figure it out because it's doing a curved path here, and then we know the radius of curvature, and we know the speed of the car, so we can actually determine this omega. The omega will be in this direction by the way. In the k direction. Cost product, the distance from B to A, plus the relative velocity of A as it is measured with respect to this frame. Okay, this is one of the equations that we could write because this frame of xy is rotating. We have this extra term. Now, if we write another equation for velocity of B is equal to velocity of A plus relative velocity of B with respect to A. Okay. Now, from these two equations, this equation and that equation, you can understand that negative of this relative velocity of A with respect to B is equal to the relative velocity of B with respect to A. Okay. And this is what the question is asking. Is the apparent velocity the negative of the velocity which B appears to have to a non-rotating observer in car A? The apparent velocity is defined as the velocity that appears to the observer that is riding in and turning with car B. Now that velocity is actually V relative. Okay. Therefore, velocity of B with respect to A is not equal to V relative. It is equal to V relative plus this extra term. Therefore, the answer to this question is no. Actually, we have an extra term, and this extra term is due to this rotation. But the negative of velocity of B with respect to A is equal to the velocity of A relative to B. So there is a distinction here because of the rotation. And then the apparent velocity to the observer that is sitting inside this car is just V relative. And in the question, this is asked. We want to find out this V relative. What do we know? We know velocity of A. We know velocity of B. We can calculate omega, as omega would be omega times 100 meters. That is going to be equal to velocity of B. So we can find omega. BA distance, well, it is given to us as 40 meters at that instant. So that information is available to us. And this is B to A. Therefore, we need to do the, this is appearing in the negative direction. So this is a negative 40 I. This is the B to A vector. Okay. So if we make use of that information and then these velocities are given in kilometers per hour, we need to change them to meters per second. These are meters per second. This is what we are looking for. And then omega, the angular velocity, can be calculated by using this radius of curvature, 100 meters, and then the velocity of car B. This is in radians per second. This is calculated. Then there is this negative 40I. This is the BA vector. That's why it has a negative sign. It's in the negative I direction or negative X direction. And then this is what we're looking for by making use of this equation. This equation that was the first equation that we wrote here. Right? This is the first equation that we have here. By making use of that equation, we are able to calculate this V relative, which is the apparent velocity to the observer sitting in car B. Now, velocity of B with respect to A is the velocity of B relative to the non-translating coordinate frame A. Velocity A with respect to B, velocity of A relative to the translating frame at B. And these are the negative of each other, but then it's not really equal to V relative, the apparent velocity that is observed by the guy sitting inside car B, because we have this extra term.